Alright guys, so I want to do a little bit of Canbus Basics. So I'm going to go over just some of the basic stuff in this. This may help you just do some basic diagnostics if you have a vehicle that has a CAN-bus communication issue or some kind of module issue. This basic explanation and some of the basic testing might help you at least pinpoint or get closer to figuring out what's going on with the vehicle if you're working on one. Alright, so we're going to start with the very basics. This here is just a very basic CAN-bus network, just to kind of show you what a diagram would look like and how the CAN-bus systems actually function. So you're going to have two lines, two wires in a CAN-bus system, your CAN high and low. On each end of that circuit, you're going to have what's called a terminating resistor on both ends of the circuit, and this is on all CAN-bus circuits. That terminating resistor is there, it has a very specific purpose, and it has to do with the messages being sent down the lines and having them not bounce back and forth. There's a whole lot of science that goes into it, and I won't get into that here, but those 120 ohm resistors need to be on each end of the circuit, and they have to be there. If there's any kind of issue with those resistors, or if they go bad, or if they fail, this can cause an issue with your CAN-bus communication. So with those CAN-bus lines, your high and your low, what you can do is take a resistance reading from those two lines. Now make sure your battery is off, make sure everything's disconnected, unplugged, but make sure all your network and wiring is plugged in, obviously. And you're going to check for your resistance at these two wires right here. You want to see 60 ohms, and 60 ohms is the reading that you would get based on having the 120 ohm resistors at each end of the circuit. So anywhere in this circuit here, you should get a reading of about 60 ohms if you were to check the CAN high and CAN. So the next thing we're checking is for our resistance from pin 14 to pin 6. Make sure you very lightly touch them in there, don't push in the pins. You should get roughly 60 ohms. Now don't forget, only do this with the battery disconnected. Do not forget to disconnect the battery. Now the easiest way to do this is going to be through the DLC connector if you're dealing with just the CAN-bus 1 system. Now keep in mind, most vehicles can have multiple CAN-bus systems. They can have 2, 3, 4, 5, some have even more than that. So we're just really talking about your main #1 CAN-bus system here. Now almost always that CAN-bus system is going to be pinned out to your DLC connector, or OBD2 port, which they call it. So pins 6 and 14 in this connector are going to be your CAN-bus high and your CAN-bus low. So this is where you're going to pick up, where you're going to check for your resistance on that circuit. Like I said, just make sure that the battery is disconnected, ignition is off when you do this. Check your resistance between these two and you should get 60 ohms. Now the other thing that you're going to want to check on your CAN-bus systems is going to be the voltage. Now this is a little difficult to do with a voltmeter because obviously you have to, the voltages are going to be changing quickly, rapidly, so it's very hard to get just a reading on your meter. You're kind of just going to see the meter reading flash up and down between kind of a certain level. But what you're looking for on your CAN high and your CAN low lines is for them to alternate between 2.5 volt and 1.5. So your CAN high line, your CAN high wire, is going to alternate between 2.5 volts and 3.5 volts and back and forth. And your CAN low wire is going to alternate between 2.5 volts and 1.5 volts, just like so. And they're both going to alternately switch randomly there and back. So what you want to do to kind of check to see if this is working or if you're getting voltage from your CAN bus is with the key on, make sure you have a decent ground. Take your voltmeter, ground it on the chassis somewhere you have a known good ground, and then you're going to check your positive in 14 and 6, pins 6 and 14. And what you're doing there is you're checking your voltage separately on your low line and separately on your high line. And what you're looking for is to see if your voltage is fluctuating between these two levels here. Again, like I said, it can be difficult to see on a regular voltmeter because some of them don't change quickly enough for you to be able to see these readings. This is where an oscilloscope or something like that comes in handy so you can really see the waveforms. But this will at least give you an indication that those wires are showing a voltage and that the voltage is moving and changing between the correct parameters that it should. If you've got a CAN high wire that's showing voltage under 2.5 or anywhere, far above 5, then you know you've got a problem. If you've got a CAN low wire that's showing some high voltage or some voltage way lower than it should, then you know you have some issue there. Alright, as we check our DLC connector, check pin 14, this is going to be our CAN low. And then if you check our CAN high, You'll see that shows about 2.8. So this is with the key on, and these are average voltages roughly. Now, pinpointing the issue can be a whole lot more difficult. A typical Canbus system is going to look like this on most vehicles. Now, this is a 2015 F-150, and like I said, some vehicles can have multiple Canbus systems. You can see here that this one has HS1 CAN, it's got a high-speed 2 CAN, it also has an MS1 CAN, and it's also got, I believe there's one other, but some other vehicles like BMW have what's called FlexRay, and others. So when you look at this hierarchy chart right here, it's going to show you which modules are on which network. Because some modules are going to be on one network, some modules might be on another. See, this one also has HS3 CAN. So you're going to have multiple networks there. And if you notice on each individual network, it's going to show you where your terminating resistors are located at the end of that network. Now, like I said before, your HS1 Canbus network is the only one typically that's going to communicate with the DLC connector. Sometimes you can find HS2 CAN in the DLC connector, but not always. Many of them have what's known as a gateway module, like this one here does. Now, what happens with the gateway module is that your other Canbus system lines are going to feed into that gateway module. The gateway module is going to be what basically interprets all of the signals from those other Canbus systems and displays all the diagnostic information through your DLC port. Now, I know this is a lot of information. It gets very in-depth. There's a lot more information that you can go a lot more further than this, but this, I hope, will at least help some people pinpoint some of their issues. Now, if you've got anywhere where it's saying that your Canbus lines are shorted together, that's typically going to mean that you have some sort of wiring issue somewhere where their Canbus lines are shorted together and stopping communication. Sometimes you may have the wrong ohm reading in the system, and this may be an indication that one of your modules has failed, or maybe the terminating resistor has failed in that module, causing you to get incorrect resistance and communication issues on one of your CAN lines. But the issues can be all different sorts of things, so I hope this will at least help people to get a basic start in checking at least your resistance on the circuit and your voltages on the Canbus circuit.